some files in the potential,
Bad as they throw hard drives away from your storage, you'll have plenty to do. Plenty of practice on.
You said you were going to go into like the business side of it too, right?
Yeah, some tomorrow I'll start, and I can answer any questions or anything you like at any point in time after dinner, after lunch, or after whatever.
Okay. I was just wondering because like liability and stuff, if something does go wrong. I was wondering if you had any paperwork because I know like Geek Squad and stuff, they have like a whole form you gotta like.
Yeah, mine's pretty simple. I have a feeling, I've always had this opinion that if you make a piece of paper too complicated and too long, that people won't sign it. So even for my forensics engagements, they're 3 pages long. My regular hard drive ones are only 1 page, and then a credit card or something form like that. The nice thing about hard drive recovery is you're already starting with something broken. So, I mean, what would be the argument in court? Like, it was broke and he broke it more? I mean, that tends to be. I've really not ever been sued. I have in my forms, I have the limitation is basically what you've paid me. So whatever you've paid me, if there's really a big argument, I'll pay you back, right? That's it. And maybe I've had 2 or 3 at the most over 17 years, but generally it's not really a problem. The biggest problem that they argue about always is, even after I've done a recovery and they've gotten a great service and they've got their stuff back, that they'll still argue on a credit card, or they'll still, like, whatever they can do to try to screw you, they'll do. All right, so let's talk about, I'm on page 187. I'm going to fly through this because we've covered some of these things. As we mentioned earlier, there's a system area on your hard drive. And I'll eventually show you a picture and the basics of what it looks like. But on that system area is a location you can store a password. And the drive will basically have a loop that it will insert in its startup process that will keep you from talking to user area. So if you have system area and user area, and your MBR, the thing that we've been looking at as the first sector, is stopped. You are prevented from even seeing that if there is a password on the hard drive. There is nothing immediately that shows you a password is set on a hard drive. It's not like you plug it in to your computer and then immediately a box is going to pop up or anything like that. Now that happens if it's encrypted and you have access to it, but that does not happen with a hard drive. So if I took a hard drive, let's say I pulled a hard drive out of a Dell, and the Dell had a password set for the hard drive, not the BIOS password, but let's say the Dell had, that's page 187. Let's say that I had set a password on my hard drive. I pull out the hard drive. Yes, we're in book 1. Sorry, we're back to book 1 because the labs were in book 2.
187.
So if I had a Dell and I set the password on the hard drive, not the BIOS of the computer, but you use the BIOS of the computer to set it. It sets the password on the hard drive. If I took the hard drive out, what it does is it prevents anybody from copying that hard drive. As soon as I plug it into any device that I'm trying to copy, if I try to read any sectors, it won't pop up a box and tell me your hard drive is locked. It will give you an error. It'll say error, 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 error on every single sector you try to copy. It'll just abort. So you generally know one of 2 things. One is it sounds pretty good. The drive, when you plug it in, it's a working drive. There's no problem with it. And it sounds perfectly fine. Nothing sounds abnormal. It doesn't have a clicking noise, doesn't have anything. It works just like it should. So that is one thing that should kind of clue you in right away. And then when it aborts every sector, but you knew it was working on that computer a few minutes ago or yesterday or whatever it was. So sometimes people send me hard drives like that because they think they're bad. That the Geek Squad did come in and do an upgrade, but they didn't realize that the drive was locked. So they pulled the hard drive out of the guy's computer, put a new hard drive in, formatted it, put software on it, but then they tried to copy the data off of the hard drive, and it's like, oh my God, the drive is bad, and they will send it to a data recovery guy. So that's how that's happened sometimes. Now, even for them, they plug it in as an external device. It doesn't pop up a box. There's nothing that you would know it has a password. Okay, our tools, the PC3000, the DeepSpar, and the Atola all have functions to reset passwords. The problem with the DeepSpars is that it's not part of the tool, it's part of a module. It's part of an add-on. So they have a drive key reset wizard. It is not the best one if you're just looking for passwords. The PC3000 is the best. Without a doubt, the PC3000 has the best unlocking tools for passwords on your firmware than any system out there. Atola's is okay, it's pretty good, and it'll certainly work in most pinches. Most of the other tools, besides the PC3000, do not do the IBM Hitachis. The IBM laptop and Hitachi laptops, they have a problem where the board has to be shorted in order to get access to it. So they have a tool that has a fuse on it, and you have to short 2 pins, and you have to know which pins you have to short. Then on the PC3000, it will give it access to the firmware in a failover condition, and then you can basically overwrite the password. That's really what's happening. Most of the tools that clear passwords on the firmware of hard drives clear them by setting them to nothing. That's really what happens. It just wipes it to 0. A lot of times, especially forensics people, want to know the password, because that password is something that's sometimes used in other passwords in other software on their computer, so encrypted files and things like that. So the PC3000 is without a doubt the way to go, because it will display more often than not the password that the drive has on it. A lot of the other tools do not do that. The Atola does attempt to. The Atola has a password location. I have a picture here. So there's a security feature on drives, and you can unlock the password, see the password, change the password. There's a situation where it can display the password, and then you'll know the password. The password was extracted, and it's super secret or something like that. So there is a setting that you can do that. Now again, the Atola doesn't support as much breadth of drives as the PC3000. So this is a function that works, and works quite often. Most of the time when I try it, it works. But by far, if I'm going to do password recovery, password reset, password clearing, I'm going to do it with the PC3000, almost always. Especially because Hitachi and IBM drives. So keep that in mind from that standpoint. There has been, and there was, a free tool. Dimitri actually wrote a tool for a company that used it for a while to reset the passwords, basically to blank. They didn't keep the password. However, this is what happens to me, and it happens often when I'm doing stuff.
That's all.
Yep. So this was one of the free. It wasn't free. It was $40. You spent $40 on this tool, and it could unlock a hard drive. So if it was a data recovery that you had gotten, you could clear the password, charge your client $800, and send that back. I mean, it's, you know, and people will ask you, you know, oh, how do you feel about charging a client $800 if it only cost you $40 to do it? Again, it's not the answer is not, it's what button to push, right? Yeah. Like sometimes our experience, and in this case now, this was one of the few software packages out there that did it. I don't even know if there are any other packages, because this one did it anytime I needed to do it cheap, that didn't include an expensive tool. The rest of them are expensive tools. So when you buy a Atola or a PC3000 or a DeepSpar and you use it even to do a small function, your tools are the only tools that could do it. That dude couldn't do it. So that's why I charge across the board $800. I'm always charging $800. So it doesn't matter whatever they send it in for. If I do a recovery, they probably don't even know what it is we have to do, but they always know my price. So the problem with being flexible in your prices and changing your prices is, you know, because people like to try to categorize them. They like to do category A, category B, category C. In category A, we do anything that doesn't require platter removal, head replacement. In category C, we do anything that doesn't require firmware, blah, blah, blah. And we have a different price for each thing. The problem is when you get to the last category and it's the highest price, and you tell that guy it's the highest price, they're always going to think that every time you talk to a client that it's always the highest price, that you're always just saying that. You get my point? Like you're scamming them.
How dare you?
Right, rather than being honest or whatever. And so that's why, you know, it works really well for me to say, if I'm doing a forensics image, it's $1,200. If I'm doing a data recovery for anybody else, it's $800. And I don't do it by size, I don't do it by meg. But at least if you do it by size or you do it by meg, you have a fixed price. It's like, oh, well, you sent me a 1 terabyte, so you know what it's going to cost. If I recovered 300 megs for you, well, you know what it was going to cost. I charge per meg. That's what it is. As opposed to, I'm flexible in my pricing, and the only one who can determine that is me, right? Oh, it's got to go to the clean room, so it's $3,000. They're like, oh, well, you're just saying that because everybody goes to the clean room, and they're all $3,000, right? That's the way it is. So in this world, to me, my tools cost me a lot of money, and they cost a lot of experience in getting there. So you should charge for that. That's important. They need their data back. Fine. If it's just clear a password, I'm fine with that.
So when you said you spent 2 months on a SQL database, you didn't charge $800?
No.
I was just wondering.
Yes. So, I mean, I have certain instances where certain recoveries are, it's not just if I copy a drive, I hand it back to you, and you have an IT guy who's going to copy the data to your drive, that's an $800 job. If you want me to look in your email, find something, and, make a report, that costs money. If you want me to, if some horrible thing happened and I've got to manually reassemble it, it's not a copy of a drive. I mean, I can copy the drive and hand it back to them. But if they want that SQL Server database and all those records and the condition is bad, they know it. They know. Almost everybody knows in those situations, this is some horrible thing that happened. You're not just copying a hard drive and handing it back.
So for rates, do you do by disk or do you?
I do charge by disk. So I charge $800 times the number of disks. Right. So so that way there's never a question. It's easy for me to say, it's easy for my employees to have the same thing. It's really great in your accounting software because you can tell every job you did by the cost of the job. Forensics jobs, $1,200. Now when I'm testifying, if it's in Georgia and I'm going to go see you at trial, I'm going to go do, I have a $3,000 engagement, I charge $300 per an hour. If you take 35 hours of my time, I'm charging you for 35 times 300. That's not a copy. Like I can do this stuff without you sitting there. I can image your hard drive. When I am done, here's an image. And that is your responsibility to go testify about it. I'm not digging the data out to hand it to you to testify. Does that make sense? That's a $1,200 job. I can fix price it right across the board. You want a copy of the phone and Celebrate spit out a report, but nothing special, and that's all you want, $1,200. You want me to plunder, do some extra work, write a report, $3,000 engagement fee, $300 per hour. It's pretty easy.
Makes sense.
So I know how much it's going to cost for every single thing. I hardly ever get an argument about price. I hardly ever get screwed and don't get paid. I mean, my losses are less than 1%. And most people in business who have, they'll normally have about a 5% loss. So my losses are less than 1% for 25 years. For 25, even managed IT services, I had it same way. We had a process, and it was the same. So from a business perspective, I figured that out. Because my biggest thing is being the owner. There's a difference also between I hire a manager who runs the business, and he's out there getting business, and then I'm a tech who goes work for him. As the owner of the tech company, I have an ethical status. I want to be the lead guy. I don't want a manager. I want to enjoy my life. So there is a difference in that process of how you actually handle yourself. And there's a difference in money. A manager is going to make a lot more money. Thank you. So at least from that standpoint, that's the problem is if I have a drive or something that I have to unlock, right now at least I'm going to tell you it's a PC3000, it's a DeepSpar or a Atola. DeepSpar is not my first to go to in that instance. I do own the modules. I do have that particular thing, but I will tell you it doesn't work in every situation. It doesn't work on every drive. Way more in depth on the PC3000.
I just had a question. The HDD unlock, was there any reason you would use that despite having all the equipment that could reset the password and whatnot? I mean, why were you paying $40 when you had the DeepSpar and the PC3000?
If you're on site, I'm assuming.
Right.
Oh, is that what you weren't? You didn't have the equipment?
I travel all over the world, and if I didn't have my PC3000 with me, I used to travel with it until, and I used to ship it until FedEx lost my PC3000. And then, I don't know if you've ever insured a package and tried to get paid from the company that you insured it from. And if you try to do it, I'm going to tell you the Postal Service is by far the worst. The Postal Service, you insure something, it's a brand new item, you sent it out, and it was $10,000 and you insured it, they will immediately depreciate it. They'll immediately be like, well, it wasn't worth $10,000. What? I insured it for $10,000. I told you it was $10,000. No, it's not. It's not worth $10,000. It's worth $500. Like, they'll do shit like that all the time. I cannot use the Postal Service for almost anything. It's completely near impossible. They never honor it. I've never gotten paid from a lost package from the Postal Service. Never. I did get my money back for the PC3000 through FedEx. I did get paid, but it took 2 months. It took like an insurance investigation.
UPS is worse.
They're both bad. They're both terrible. Anyway, so So my PC3000 is pretty valuable to me, and we need it in the office. And as expensive as they are,
You're not going to take it with you.
I'm just not going to have that many. Yeah.
And you can log in through the network.
Yeah, right. I mean, I can do most anything I need. Somebody just has to plug in a device. That's the only thing. So,
I mean, I don't even know if they exist, but if you had one of the products we make at our company is a virtual USB tether, but if you had a virtual tether, could you connect it to the PC3000 remotely and do them? I assume it wouldn't carry as long as I thought it was physically connected.
there's a lot of things when you're talking ATA commands, you're talking to the drive. I can remotely control a machine. Putting the drive someplace else may be a way more difficult process. So it's just not the best from that standpoint. Anyway, all of the tools have a screen that's something like this. The PC3000 in many cases will just show it to you immediately. Most of the time, passwords are in clear text. They're not encrypted. They may be obfuscated. Like for instance, Dell likes to do this kind of like ROT13 kind of thing where they rotate the characters so it's obfuscated through the BIOS so you don't know what the password was. Everybody's figured that stuff out. It's nothing. And once you've set that password, that is the password. So if your password is parentheses 777 and you obfuscated it and it used to say, I'm the man or something like that, it's still parentheses 777. It's only I am the man because it passed through the Dell BIOS. So just understand that that's all you're trying to do is there is times where there's password. Now, I will tell you, there is an easy way to know, and you can do it in any tool. You can do it in a free tool. You can do it in, and I'm gonna show you the free tool, because here's the problem everybody says: how do I know if it has a password and it's not just an error and the drive isn't just dying? Right? That's the real question. So I'm gonna do it with a free tool. On the laptop in front of you, there is a Windows tool called Victoria. See it? Has a big giant. It's also written by a Russian. Apparently Dmitry knows him, and he went because Dmitry made MHDD, and the guy who wrote Victoria wanted a Windows version, so he basically took MHDD, or that's what it looks like, MHDD as a Windows version. So when you run Victoria, so here is the thing. You see this right here? So in the ATA commands, there's a request for do I have a password? And so if it is set, see security is off. If security was on, there's a password. So before I ever even read a sector, if I actually looked at it now what's passport? It's called drive passport because a passport is information about you. So they're not real creative on what they actually call stuff, and so that's why it's called disk passport in all the other tools as well. So you're getting a passport about the drive. Yeah.
This is frozen.
That would be if the command was there, you could actually freeze it. So in this case, this is the live operating system, and my expectation is the reason that it's just saying frozen. I understand this is text. This was converted from some bits. It's not actually saying frozen, but my guess is that because I'm on a bootable system, there's certain functions you cannot do. So in this instance, though, security is off. And these are the commands that are supported. You can see a lot of things from the commands. Now, that's one tool. You could use MHDD to do the same thing. Anything that gives you the disk port information. But as an example, if you had a deep spar, here's what it would be in a deep spar. I hit F11, turn on a drive, hit R. Now I have a drive running. Is the original, because you'll see this stuff. It will work fine. You'll see even the passport, even if it's locked, even if you have a password, you cannot read user data, but you still read the system area. So you still get model number, serial number, and all the information. It still looks like normal. Hit OK. Then I look at the source drive. So I go to the source drive, and I do disk passport. It tells you all the information about the drive. You scroll all the way to the bottom, and you will see two sections. You'll see one section that says supported commands. So you see security, which is password protection. Then you see the one called enabled commands. If you had a password, it would be enabled. Okay? So you can see everything that your drive can do, and you can see right now, like enabled, host protected area. So I have the setting on for host protected area on this drive. Okay? This is cache. Like you have 2 megs of cache on your drive. The cache is on. DCO is on. Advanced power management does things to cut down so that it spins down when it's not active. It also cuts down on noise. It like moves slower because it's active versus enabled from a noise perspective. The microcode command is able to like reprogram the device on the fly by injecting into memory. Smart is on, so it does have the self-test, and Smart is on. Smart error logging, so it is currently saving logs if there is errors. And then there is a general purpose log, which is a system log that the drive actually does on its own. So there are things like this you can tell about your drive in the process. And all of the tools have a function like that, including the Atola. So the Atola has the ability to do a little bit more, and I'll get to that because it's a whole thing all in of itself, because it does diagnostics and shows you all the bits all at once. There's ID logging, all kinds of stuff. But I just wanted to let you know there's free ways that you can tell. If those are on and it says security is enabled, then you would not be able to talk to that drive, do anything with that drive until you clear a password. Once you clear the password, then you can copy the data. Sometimes that's all you have to do. Sometimes there's nothing wrong with the drive. Everybody understand? This is about one or two a month. There's not as frequent as they used to be. They used to be fairly frequent. We would get them, 5-6 years ago from people using Dells and things like that. But it's not real frequent anymore. Some of this other hardware just really expensive to get that done. So some of the other things I need to talk about are ATA standards. So just like the HPA, which we briefly discussed, you chop the drive, that's an HPA, that is an ATA command. So ATA is Advanced Technology Attachment Adapter. That's basically what that is. That's IBM's terminology from way back in the day with the PC, AT, and things along those lines. So they're technology adapters, basically. So when we finally came up with a board who decided, okay, we're tired of this cavalier attitude you guys all have making hard drives where things don't match. We don't have jumpers. We don't have two drives that can match and work together. And you've got to hack a ST506 board. So back in the late 80s, when IDE comes out, they came up with some ATA standards. Prior to the first set of ATA standards, there was nothing. It was Cowboy City. Okay, you can do anything to the drive you want. Hope for the best, basically. So we used what's called programmed input-output mode. Every single transaction went across the bus. It was really slow. You had to make every request from the operating system to the drive for every single thing. There was no programmer's interface by comparison. You were making every command yourself. Very slow, but sometimes when we fall back to that now, if I was reading or writing, I might want to use PIO mode because it may be more stable than using DMA or some faster mode. So we do switch back and forth in data recovery to PIO mode all the time. So we'll go back and forth between DMA and UDMA, which are faster modes of reading, back to slower speeds in situations where something's unstable. And sometimes we can read it. The other thing that we also do is we change direction. We go backwards instead of forwards, which also does basically turn off the cache. When you go backwards, cache only goes forwards. So when I go from 0 to an LBA number, it caches forward in advance of me. When I go backwards, it's individually transferring blocks. It does not cache in the other direction. Does that make sense to everybody? So there's a poor man version of turn off the cache, but there are commands in the advanced tools to turn off the cache. But if I just wanted to do it the poor man way, I'd just copy backwards. It doesn't actually turn off the cache, but because it is transferring a block at a time in reverse and it can't read ahead, then it is more stable. Sometimes reading backwards is the only way a drive works. I promise. You'll see it. You'll see it happen. You'll make it happen.
You do that with all three of your...
Yes. Almost every single data recovery tool has a forward and a backwards. Almost no forensics tools do. The only one that really does is X-Ways. They had a command line tool, and they have another way in the interface to go backwards. So Stefan is well aware of these things, and he and I have had discussions about these things. So those are the only ones that can do it. He did sunset his command line tool, but you can still get it. You can still use it. All right, anyway, so then we finally move into direct memory access, where we can transfer items without having to go completely across the bus and using all the cycles. So DMA there are a ton of DMA modes. So they all increase speed as we go, but sometimes things go wrong. Memory transfers don't work. A piece of memory is bad. Remember, these drives are built from things made with, a nickel. So you're buying a 40 gig, a hard drive, even a terabyte hard drive for like $40. How good are the parts in that drive? Probably not too good. I mean, there's a lot of science going into this. They're doing everything they can to cut those prices down, so they're buying memory from whoever is the lowest price vendor in China, right? So memory is one of the biggest things that goes wrong on a drive. If you can turn off DMA, in a lot of cases you'll be able to read, but it'll take you forever. If you have a 2 terabyte drive and you try to read that in PIO mode, might be 17 years. It can be. You can figure it out. But I'm just saying, so what you're looking for is the sweet spot. I'm not kidding. You will see drives that do that. Am I kidding? There will be times it'll actually say 17 years. Yeah. Right.
Slow, but for 4 months it's considered
Right.
slow.
And what's the alternative if you tried to do something to make it faster?
It'll just shit itself.
Shit itself and fails, right? So 4 months is better than never saw it again. Right? Slow is better than no. No matter how you look at it, slow is better than no. So I agree with him 100%. You don't want to do anything that will detrimentally affect that. So, but what you are looking for is the sweet spot. There maybe, even though it supports DMA 6, that if you went to UDMA mode 3, it may be faster and not fail under that condition. It's a completely different piece of code running in a different ATA spec. So your drive doesn't have to do just the one thing it does when you power it on. You can adjust all of those settings. You can do some of those in Linux with HDParm. You can set some of those settings, but it's really nice to be able to do it on the fly on a DeepSpar or an Atola or something. And then as we get into ATA2, this is very important, ATA2. There's a lot of things in all the ATA commands. I don't care about all these other things. I only care mainly about these 5 or 6 things I'm talking about. And ATA2 had a command in it that's called read long. And so you had the ability to ignore ECC. So in LBA 28-bit mode, now remember, when we're addressing a drive, when we talked to a drive, we had so many bits that we could send and transfer data. It was originally 32 bits, but we cut out 4 bits to use them for some reserved flags. So we can transfer data at a certain speed, but we can only address a drive up to the number we can count to. 28 bits, okay, 28 bits will only go to 137 gigs. So if you have a drive that's 2 terabytes, even if you were able to make it go to ATA command 2, you can only address it using that mode up to 137 gigs. That is a magic number, because there is no drive created that's 137 gigs. Does that make sense to everybody? Because you can use one command from ATA2 that was not available in any other mode, they sunsetted it after this. They made it obsolete. They decided never to use it again. They said we didn't need it, which is terrible because it's actually a very useful command. But it's called ignore ECC. What it means is I read a sector and we have ECC at the end of the sector. If you compare the two, there may be an error in the sector, but ECC says, oh, well, there's an error, it didn't match, and my error correcting code is not good enough to fix whatever that problem is, so we decided, bad block, give you 0. This is what we talked about yesterday. Every forensics tool does, it spits it out and gives you 0. This is why. Because as soon as it gets a bad block, it reads that, it knows it's not guaranteed, so rather than giving you a guess, it just says, doesn't match with ECC, so therefore, throw it away. Everybody understand what I mean? What if I could say, I don't care if it's bad, give it to me anyway. I'm going to ask you for it 99 times. And 99 times you give me an answer. If I line all those answers up in an array, and I say 50% of the time you said this, and randomly all the other times you said something else, I'm going to take that 50% win. Does that make sense? 50% of the time it's this. I'm taking that. It's a guess, but it's a pretty good guess. Understand what I mean? That's what we're doing. That's what the DeepSpar does. That's what the DeepSpar does better than any other tool out there, is they build a bit array. It used to be a byte array, And again, it was something I brought up and begged them to do. They switched it to a bit array, and now the bit array actually monitors every single bit in the flag and then builds an array however many times you tell it to build the array, and then the answer will be better than it ever was. So the DeepSpar can do that. No other tool does that way. Nobody else builds an array. PC3000, I've had that discussion. They've actually come to my office and we've had that discussion. They don't understand why I want it. I don't understand why they don't understand that. But they don't understand why I want it. They've actually asked me for like demos to show their developers or something. But like, just get a DeepSpar and go figure it out. Right, there's one in my video.
It is in your video.
I went on DeepSpar yesterday. They still sell the PC3000.
The what?
I went on the DeepSpar website. They still have the PC3000.
I don't think you can buy the PC3000. They still support, but I don't think you can buy it from them anymore. I'm almost certain.
It's on the drop down menu.
Yeah, it might be there, but I don't think you can buy it from them anymore. They got into a big fight with Ace Laboratory. Ace does not want them selling the DeepSpar. That's the problem. I'm pretty certain you can't buy it from. Try to buy it. Try to buy it. Just call Serge and ask him. Serge.
Well, you have to call for pricing. That's all it says. Call for pricing when you go on the DeepSpar website.
So we can't say that, but we can say this.
Right, exactly. Right. Yes, they can still support it, but they cannot sell it. That is my understanding. So, anyway, so just keep that in mind. 137 gigs up to 28 in LBA 28-bit mode. After that, you've actually got to switch to 48-bit mode, which is what we're on now. Now we're at 48-bit mode. So 28-bit mode until we got to 137 gig drives, which was around 2002 or so. And then switched to 48-bit mode. In the meantime, we came up with other stuff. We came up with self-monitoring, analysis, and reporting technology, SMART, which we've already talked about. Host protected area, which I'll mention again in a second, but we're just chopping off the end of the sectors, right? And then CF adapters. In ATA 5, compact flash, which is a professional, basically that's all it's used for anymore, is professional cameras, right? It is unique. It is the only memory on any spec that is its own ATA spec, which means I can do recoveries from CF sticks as if they are hard drives. I can use the same equipment. Every other piece of memory plugs into a USB adapter and converts to something that you can plug into your computer. Even if it looks like an IDE adapter, it's got a built-in USB chip. It's converting it to USB and then putting it out. There is no memory, no other spec on earth that does not convert to something else except for CF. CF is the only one. So if somebody sends you memory sticks, you can actually get the little adapter, plug it straight into the DeepSpar, and do a recovery off of it. Just like it's a hard drive. It acts exactly like a hard drive. Then we get to ATA 6, which is where we got 48 bits. It's really 64 bits. They reserved some bits. And that's where we are now with to get past 137 gigs. So we're not at our limit at the moment. We are fine. And then keep on going. They've added other specs. Hybrid drives originally, they've changed now. Hybrid drives used to be really driver dependent. They're not anymore. So they still do use a driver, but not in the same way that they did before. So these are the specs, and I'm going to show you in a DeepSpar, Atola, PC3000, I'm going to show you how we are basically moving between them, because those are all your choices. All your choices are affected by all your ATA specs. Which spec do you want to use, and which commands are you using from them? So in the DeepSpar, you'll actually see that. So what we're looking at is 4 primary things, which is speed, PIO mode, and DMA mode. Those are your 2 choices, PIO and DMA, okay? 48-bit and 28-bit, those are your other 2 choices. Switching between 48-bit and 28-bit. Then you get different functions you can turn on and turn off. If you want to read ignoring ECC in 48-bit mode, it's not coming from the drive, it's coming from memory. It dumps it to the card on the drive, and then you're pulling it from the card on the drive. And if anybody's done memory analysis before for forensics or anything, you know it's a disaster because it overwrites things, leaves chunks in memory. There's all kinds of stuff that'll be left behind in garbage. So it's harder to do in 48-bit mode. And so that's what we're switching back and forth between almost all of them. So now when we come back from lunch, now the host protected area we did already discuss. Basically we're chopping off sectors out of the end, and we can reset in the HPA system area the original size. So it always is accepting that size. It is a number we can write there. And then DCO we talked about, which is the same basic thing. They go together. Okay? And then following this, we're going to be talking about now imaging. I'm going to go through all of these things with imaging when we come back from lunch. Then we're going to go trial by fire, even though we're not going to follow exactly in the book at this point. I'm going to demonstrate to you all the things you need to do to start taking apart a hard drive. And the rest of the day is going to be labs. I'm going to be helping everybody one at a time as we're going through things. Disassemble a hard drive, pull platters, everything out. We're going to write data to a hard drive, and then we're going to disassemble and destroy the drive. And then we're going to put it back together and make it work. Everybody good? And we're going to do, like, you should probably do 3 or 4 drives today, each of you. It'll take about an hour, hour and a half per drive, somewhere in there, maybe 2 hours, depending on how fast you are. So that will take, 3 to 5 hours, depending on how quick you are with doing that. But that's what the plan is for the rest of the day, is to go over those things, and then I'll hit anything else that we missed before. But we'll use most of that from the last half of the drive on, from the last half of the book on. Okay? Let's eat. 1 o'clock.